Okay, so this is Mrs. Bejo. This is lesson 2 in our module 1 AB packet. So today what we're going to do is we're going to continue with constructions, and our opening exercise is the following. So the following exercise says 2 homes are built on a plot of land. Both homeowners have dogs and are interested in putting up as much fencing as possible between their homes on the land, but in a way that keeps the fence equidistant from each home. Use your construction tools to determine where the fence should go on the plot of land. So I will pause the video and try to remember what equidistant means. Once you have an idea, you can come back and start drawing. Okay, so now let's continue. Um, so let's try to understand how can we possibly find out where should I put this fence. So there has to be a fence that has to be between both houses, so it's fair. And so far in construction, we learned how to draw circles using our radius. And we noticed that we need to have a center before we begin to draw any circles. So we're gonna place our first center at H1, and we're gonna draw our first circle from our radius will be from H1 to H2. So as you can see, my center is at H1 all the way to H2, and all I'm gonna do is just gonna go all the way around. Now we're going to repeat this step once again. And now my center is not going to be at H1 anymore. My new center is going to be H2. And I'm going to go ahead and draw a second circle. Okay. As you can see, they both have an equal radius. So make sure both circles look pretty much the same. So now stop the video and think about where should you put the fence. So in this case, it would be the same distance from both houses. Okay, so now let's draw our fence really quick. Let me move this out of the way. We're gonna make it in purple. So we will say, well, it has to be exactly in the middle. So if I draw a line that goes exactly in the middle of those 2 points of intersection, I could say that it's pretty much in the middle of those 2 houses. Keep in mind that you should continue to label your points of intersection. That way you remember what did you do? What were the steps that you were doing? All right, so focus on how do we get to this? We need a center to draw our circles, and we need to make sure we use the correct radius. All right, so let's move on to the next page. Read this for a minute. Try to understand what it tells you. Pretty much what it's asking you to do is draw a few circles, exactly 3. So it's using the skills you have practiced, construct 3 equilateral triangles where the first and second triangles share a common side, and the second and third triangles share a common side. So let's begin. So we're gonna draw my first circle. I'm gonna make it big enough. So I'm gonna say, well, this is my center A. And I'm gonna make my first circle right here. Okay. It says we need to draw 3 equilateral triangles. They all have to share one side. Okay, so let's make our second circle. And in this case, I need to choose another center. So maybe I'll do it over here in blue. I'm gonna call it maybe B. Now I need to make a second circle now, center at B with a radius of BA or AB. So we go all the way around. That's our second circle. Okay. And if we look back in the previous lesson, how do we make triangles that share one side? Well, in this case, I could say my points of intersection were, let's keep going with the alphabet. C and D, right? So I could start making equilateral triangles. My first equilateral triangle will be somewhere here. There's one, there's another side, and there's another side. That's one triangle. Let's make another triangle. Here's one. They're sharing a side as well. They share an AB. Let's make another circle because they're asking me to look for a triangles or three equilateral triangles that are sharing a common side. So let's move on. And in this case, we'll probably make our our point D our center, so we can see what else, what other triangles can we draw. So in this case, what we're gonna do is we're gonna center at D. I'm gonna flip this a little bit, and maybe I'll say DB, and we'll make a circle. I'll make it in red, so it's a little different. Okay, so we'll make it in over here. Notice that all three circles are pretty much the same. Oop, I forgot a little part of the circle. That's okay. All right, so once again, we have to label our points of intersection. So I'll continue doing it in green, so that way we continue that. So let's call this maybe E and this F. Okay, so let's see. I think we should be able to find more triangles. You may be able to find more than one. I'm just going to label one of them. I think you should be able to find a third one, a fourth one. So I'm going to say, well, ED, EA, and AD. They just share one, exactly one. And if you're curious to know about the fourth one, you could also connect DFB. Okay, so now we follow our steps. We made a few circles. We found our three equilateral triangles. We can say for sure they're the three equilateral triangles because they're all sharing the same radius. Now let's keep going. It says if we were to continue using this procedure to construct three more equilateral triangles, what kind of figure would we have formed? So let's look back and see if we continue doing this, what would happen? What I want you to focus at, I want you to, if you want to attempt it, draw more circles around the black circle. So center at A. Okay, so let's see if we continue doing this and draw more and more circles. What shape would you find? So I'm just going to make one more, just so we can see. Now I'm going to make it in red. So again, my center in this case will be E. And I'm going to say my radius is going to be from E to A. And I'm going to make one more circle. Okay. So if I continue labeling this and I make more triangles that are exactly connecting where they intersect, let's call this G, you can notice some pattern and shape. So focus in the circle's center with the center A. So yes, the answer will be in this case a hexagon. A regular hexagon because it has all same sides, right? 6 sides. Okay, so you can pause the video and make sure you're following the steps. You could continue drawing all circles. You can finish drawing the hexagon. Otherwise, if you have an idea what it is, very good. All right, so here's just another way to do it. I draw the steps down in case you were a little confused on how to do this and how to draw this from center at where or what circles we were drawing. Step 2, where it says construct C little a and C little b, radius AB, just means center at A, center at B. So make sure you pause the video, copy this down in case you need it. Otherwise, make yourself some notes that you should be able to use eventually. All right. All right, let's continue. Example 2, you will need a compass and a straight edge. As a class, we are going to construct a hexagon inscribed in a circle using the previous example as a guide. So there's another way that it might save us a few steps, might save us quite a little bit of time. Instead of drawing all these different circles all the way around the center circle, so we could use a different approach to make sure we still draw a hexagon, and it might just be a little faster. All right, so once again, pull out your compass, make sure you have some colors available with you, and let's see. So my compass is right here. I'm gonna draw my center first. That's something you should always do. I'm gonna call it A. And I'm going to make a circle, not too big, not too small. Okay, so we're going to go all the way around A. That's my circle, center at A, so we can call it CA. Okay, now what we're going to do is the following. We're going to draw a radius. So we're going to say, well, from here to B, it's my radius. And I'm going to put a line there so we can see what's going on. Well, all right. So there you go. There's my radius. Now what we're going to do is the following. We're going to not center at 8 anymore. We're going to center from A, actually from A to B. Make sure we have a good accurate measurement from A to B using my compass. And we're not going to move. We're going to remember exactly which holes are we using. Okay, so keep in mind from your center, from the middle point in the middle of the compass, all the way, you're probably going to have to stick out a little more where the red circles are, the red holes are. Okay, so make sure you remember which hole you're using. If you forget, you can always go back to use your AB and measure your radius. So now we're going to move our center a little bit, and now we're going to use center B. And we're going to start drawing some marks, just using the same distance. Notice I haven't made my compass any wider or any narrower. And we're just gonna make a few little marks. Okay, so now I'm moving on from center B, and I'm gonna call my new intersection, that's going to be my new center, okay, of my compass. And I'm going to make some more marks. Once again, center right there where the point of intersection is, we're going to make quite a few marks. Once again, center at the new point of intersection, we're going to make one more mark. And last but not least, right here. Okay? Yours might look nicer than mine. Mine could be a little off. Now, as you can see, you have to leave your marks and labels available during this exercise. Okay, so now we're gonna do the following. We're gonna connect exactly each point of intersection. So I'm gonna make my line purple, and I'm gonna go from here to here. So make sure you don't have an arrow. There you go. And we're gonna go from here to here, from here to here, from here to here, from here to here, and from here to here. Okay, as you can see now, this is a much cleaner version of how to draw a hexagon. This doesn't mean the other way it's not, it's different, it's just less going all the way around drawing circles. So it's pretty much the same thing because we were going back and using the new center, our points of intersection such as C, D, E, F, and G. Okay, so pause the video if you need to make some notes, or if you need to write something that you might have a question with. You could ask your teacher tomorrow. Okay, let's continue with the next question. How could you connect the markings differently to make an inscribed equilateral triangle? So take a look. Maybe you have an idea. How can we make an inscribed equilateral triangle? Once again, inscribed just means that the new polygon has to be touching our circle in this case. All right, so yes, you're correct. So our inscribed triangle in this case would be if I draw something like this. If I start right here, and I skip the next point, and then I skip this other point. Oops, that doesn't look as pretty. I skip that other point of intersection, and then I skip and connect those. Right, as you can see, that is an equilateral triangle because we're just using the same distance from one point of intersection to the other one, skipping the middle one. Okay, so if you need to take some notes, I also use the longer version so you can see what was the difference between those two. You don't have to use this step. It's really a cleaner, the previous step was a cleaner version of this. Instead of drawing circles all the way around, we just making little marks. Okay, as you can see, the red one, the red over here will be eventually my hexagon. How could you connect the markings differently to make an inscribed equilateral triangle? Like I said, by connecting every other vertex, example FEB or CGD. All right, you could take notes, you could work on it once again. If you have any questions, you can ask your teacher the next day. And last but not least, we're gonna just write down some of these definitions. Very important, so take a minute and make sure you're writing these definitions. I'm still missing a couple of those just because I couldn't draw it. In this case, would be a plane contains at least 3 non-collinear points. So make sure when you go back to the classroom, you ask your teacher about some of these definitions. I think it will be very important if you are able to see something, a visual, and make sure you understand the difference between those definitions. Okay, so I'm gonna leave those two so your teacher can actually draw it and make it a little more comprehensible. All right, so let's move on to the next question. 1 through 4, sorry. How many planes are shown in the figure? Make sure you're using the definitions above. How many planes are in the figure? Well, we need to count exactly how many sides. Again, it would be ideal if you're able to see it, or if you have a shape that it's similar to it, and you have another plane, the shape on top of the plane. So we can just count that as, I'm gonna try to use highlighters. So one, right? 2, okay, 3, there is a third one right here. I'm gonna make it with using a blue marker. So this is the third one. I also need to understand that I'm including this part of this triangle right here and whatever it's in the back of the this shape. And then last, also it's a little hard to kind of show you this, but there's also another plane that goes, it looks like a rectangle, F, A, C, and D. They go on the back of this shape exactly. So make sure you know that there's exactly 5 of them. Okay, 1, 2, 3, 4, 5. How many of the planes contain points F and E? So look at the points F and E and let me know how many of these planes contain these 2 points. So as you can see, F and E is part of this plane right here. Okay. And it's also part of this plane up here. Now I can't say that it's also part of the plane EDFB. I'm talking about this because only E is available. It's part of this particular plane. Okay, so make sure you only have 2 written down. Name 4 points that are coplanar. Remember, go back a little bit with on your notes and make sure you know the definition of coplanar. You can always write it down somewhere. Same plane. Okay, so we can say, well, 4 points that are coplanar. I could say that is EDCB. Right, that's one option. EDCB. Another option could be FEBA. And my last option should be the one that's all the way in the back or behind this. It should be FDCA. Okay, so it's 4 points that are making that are coplanar. Are points A and B and C coplanar? Explain. So A, B, and C. Let me erase this a little bit so we can see a little bit more. A, B, and C, are these exactly coplanar? Yes, they are, all three of them. They are exactly on the same plane. They are all on the plane W. Okay, so make sure you're taking notes. Again, if you're still having difficulty with the definitions, speak to your teacher tomorrow and let them know what your questions are. Okay, guys, make sure you do your homeworks and stay in school.